All right, so today we are talking about chapter 3 of this book, Physically Based Rendering. And we will just continue delve into the PBRT code base. This chapter is mainly some like geometric utilities, like point vectors and rays, so nothing too complicated. First, short description of what a coordinate system is. So coordinate system are they are composed of linearly independent vectors. And yeah, it forms a vector space basically. And the important thing, I guess, is the handiness, that there are left-handed and right-handed coordinate systems, which is just convention. And different softwares use different conventions, so we need to be clear which is which. And PBRT used a left-handed coordinate system. And here, this is a description of what left-handed and right-handed is. And the second section is about this is a base class for vector. But PBRT distinguish between vector and point. So they have this n-tuple base class that is used for both vector and points, which it contains public members like this, and use some CRTP trick to mix in and nothing too substantial for this. There is they do this has-nan check quite aggressively in the code. And for member functions like this, they need to work for the derived type. So they need to use some CRTP trick like this. For people who don't know what CRTP is.
I think CRTP is a bit magical before you really come to grips with the C++ templating system.
Yeah, I don't want to explain that, but because it's not easy.
Yeah. Well, we'd be here all week.
Yeah. So, but basically the idea is like we want to share this code for both point and vector. And something normal inheritance in C++ just can't do. So we need both inheritance and template like this.
That's needing both of those just wild, but I appreciate that they're at least trying to cover some of the more fundamental things because like I can so imagine a textbook all about rendering being like, well, those are implementation details to the language you're using. We don't need to worry about this. But this book's more like, well, we have to cover those details because those are important, even if it doesn't go into great lengths to detail them.
Yeah, yeah, I really like these books that covers theories, but also just all the implementation details of the render. And yeah, there are a bunch of utility functions for tuple 2 and tuple 3, which can be used for both vectors and points. And yeah, then there's vector. So vectors are like inherit from this tuple 2. That's how it get all the stuff from tuple 2. Vector 3 is the same. This is quite like how I implement the stuff in my math library. I also use CRTP in a very similar style. Those are like lengths, just very common functions for vectors. Dot product. This is an interesting function called angle between that calculates the angle between two vectors. And it also uses this safe a sign function assumed to avoid some floating point precision issues. Oh, and also Gram-Schmidt, another really interesting, not widely seen function. So Gram-Schmidt process, basically you have one vector and then you have multiple vectors and you want to form a like orthogonal basis. Like after this process, it will returns another vector which is orthogonal to V.
So this isn't a cross product, but could output effectively the same kind of result. I mean, it's not giving you the cross product, but it does give you a orthogonal vector to two basis vectors.
Yeah, yeah. So that's the thing. Like we often use cross product in shaders because we're dealing with 3D stuff. But Gram-Schmidt's process is general. It can work for whatever dimensions. But just like in 3D, we can just use cross product to fake it. Also, I like this function. Is like it takes two vectors. We don't need to like we already have two vector to generate the third one. We can use the cross product, but if we only have two vector, then yeah, this seems pretty good.
Is this more efficient than a cross product?
I have no idea.
So I think the issue, like with the cross product, is so what happens? So thing I was always like trying to figure out is like you have a vector and you have like a up direction or something, and you want to figure out the third vector, right? And then there's a problem if they're collinear or something.
Yeah.
I don't know. I guess that doesn't really solve that problem.
No, if it's collinear, I don't know.
Yeah.
Probably this thing will just return 0.
Yes.
Really?
Now you would just get V back, right? Yeah.
Yeah.
Does V and W have to be orthogonal?
No. But afterwards, we will have something which is orthogonal, not V, I'm sorry, it's to W. Afterward, we will have a vector orthogonal to W.
Okay.
Because we like subtract the parallel component of V. Like the real branch mix process not showing here is like they actually do this in a loop so it can work for arbitrary number of vectors. But in here we just deal with 2. So yeah, cross product. Here, this is another interesting function that you just have one vector and then generate a coordinate system. I probably can learn from this because I think what we usually do in shader is to pick an arbitrary up vector and use that to then generate a coordinate system. But then the problem is that what if your vector is up vector?
Yeah, that's the problem that I was talking about, actually. Yeah.
Yeah, so I think a trick I often use is if your vector is up vector, I just pick another up vector. Like I check whether the dot product is large enough. But yeah, this seems to be better. It's complicated though. And points. So yeah, sorry, does someone want to say something? No? All right, so PBRT distinguish between point and vectors. I like that. I also do that in my math library.
I flip-flopped between thinking it's a great idea and a bad idea. And part of it is because
Yeah.
it's the rigor of knowing which is which means when you do math, you have type safety saying, hey, you're trying to, multiply a point together with another point. That's meaningless. But with shader languages, it was so often that the math you're doing is not on positions, but on like colors that a point like type would get in the way. But if you're doing ray tracing on the CPU and you're using not GPU shading languages, then I think having a point class actually is a very nice thing.
And I think the big thing, if I remember, is that they transform differently, right? Like when you transform a vector, you don't want to translate it. You just want to rotate it and scale. So if you only had one type, then when you multiply it times a matrix, what is it supposed to do? Is it supposed to do the vector transform, or is it supposed to do the point transform?
If you want to, when you convert it into homogeneous coordinates, then for vector, it will be like the W coordinate will be 0, right? And
Yeah.
for,
Yep.
I'm more specifically saying the ergonomics.
oh, sorry,
of
for the point, it should be 0, right?
Oh.
For the vector, it should be 1, yeah.
No, for point, it should be 1, right?
Yeah, that's my understanding as well.
Yeah. Because then the 1
sorry.
times the translation vector
Oh,
in
yeah,
the matrix. Yeah.
But my thoughts are just about the ergonomics of using a vector class for non-vector
Mhm.
purposes.
Yeah,
That's
you
when
can-
it gets
yeah.
really annoying to use because,
Yeah.
or actually, maybe
Well, you
I'm
could just have
overthinking
another
this.
vector class, right? You could have point, vector, and like everything else.
Actually
color
not sure
class.
what operations can you not do on a vector. It's not the vector that's the problem, it's the point class. So
Well,
actually
I think it has to do with transforms mostly, right? You have
Yeah, it might be.
Yeah.
Well, it's been a long time since I've thought about this too in great detail, so
I think, well, in my library, I do implicit conversion from point to vector, but not other way around. And I think that's also there I explicitly delete some operations for points. Like you just can't add 2 points together, for example.
Can you subtract 2 points to get a vector?
Yeah.
Yeah.
And PBRT also have normals because normal also transform differently. Think from the geometric algebra perspective, like a normal is really a bivector, right? Rather than a vector.
Yeah, when you transform a normal, it's like transforming a plane, right? So you actually have to transform to more than one thing.
So yeah, mainly for the transformation, normal behave different than a vector. So this is a helper, just we sometimes need to want to align normal to a particular direction. Yeah, I think that's it.
certainly a refresher of the basic vector stuff.
Yeah.